Alright guys, so here's my lesson for graphing equations not in slope-intercept form. Now before we even get into it, slope-intercept form. Does anyone remember what this is? Just all in letters. Take a second, write it up here for me, and see if you can get it. Hopefully you put y is equal to mx plus b. So we want to graph things that are not like that today. So after you leave here today, you're going to be able to take any linear, which means straight line, and put it in slope-intercept form. Now, every linear equation I've given you so far, you've been able to graph by looking at two things. Do you guys remember what these two things are? They are the slope and the y-intercept. Now, unfortunately, it's not always this easy. Every equation I've given you so far has been in slope-intercept form, but typically, and a lot of times in real-life situations, it's not true. In this case, we need to do one extra step. We need to put it in slope-intercept form ourselves. For example, here's an old state test question. As you can see, I copied and pasted it. And take a look at this equation. That's a little bit different than every other equation we've done so far. Can you guys think of how it's any different? Well, hopefully you thought that the y isn't all by itself. So what we're going to do today is we're going to get that y all by itself. I started to say down here, this is not in slope-intercept form because it's not solved for y, which basically means y isn't all by itself. So the goal of this lesson is to make sure we know how to solve for y. And then after you solve it, you can just do what we've been doing by using those two things, the slope and the y-intercept. So why don't you change to the next page, and I'll show you how to do it. Now the cool thing about this lesson is that when you're solving for y, we're going to use all those same rules that we learned when we solved equations that only had an x in it. So we're going to review some of that stuff. And that's what I start off doing here. Let's practice by solving equations with only an x. Remember, every single time you're supposed to draw a line down separating the two sides, the two different expressions. And the first step every single time is simplifying. Now, I can't simplify anything over there because they're not like terms, and neither are these guys. So then the second step, this is the one that I always get upset because you don't do this in the right order, is you need to get all the variables to one side. And it's always easier to move the smaller one, so in this case, we're going to move this 3x. So let's get rid of a positive 3x. Now, how do I get rid of a positive 3x? I take away 3x's, but because it's an equation, it's a balanced scale. If I take away from one side, it's going to get too light, so I need to take away from the other side as well to rebalance it and draw my big old addition line right across. Now, negative 5 plus nothing is negative 5. These will end up canceling out and making 0, which is not necessary to put, is equal to 5x minus 3x is 2x's plus 1. This still is not solved, though. Does anyone remember what type of equation this is? Hopefully you answered a two-step equation. I'm going to subtract 1 on both sides to make it a one-step equation. And I end up getting negative 6 is equal to 2x. My last step for this is to divide by 2. And I end up getting negative 3 on this side, because they're not happy to be together, is equal to, these 2's will cancel out, and all that's left is x. So there's my answer for that. Why don't you guys try this one, pause the video, and then after about a minute or two, you can unpause it and we can check it. All right, so hopefully you had enough time to try this one yourself. We're going to do it together right now. I'm assuming a lot of you guys added 4x's to both sides. It's actually a little bit easier to add 5x's to both sides, but seeing that I'm assuming that you added 4x's, I'm going to do that as well. So add 4x, add 4x. These end up canceling out, making 0. So all that's left over here is positive 11 is equal to, on this side, I have negative 1x plus 1. Obviously, it's still not solved for, so I'm going to subtract a 1 on both sides and end up getting negative 1x equals 10. But again, it's still not solved for. We want just a single 1x right here, so I need to divide by whatever number's in front of that, which happens to be negative 1. So I'm going to divide this side by negative 1 and this side by negative 1. These will cancel out because they're happy to be together. And I end up getting x is equal to 10 divided by negative 1, unhappy to be together, 10. So x equals negative 10. Hopefully you guys got that. If not, hopefully you see where you made your mistakes. So now let's use those rules to help us get y by itself on example 2. And then after we do that, we can find out what the slope and what the y-intercept is. So I'm going to draw my line down just like before to separate my two sides. But instead of combining like terms or doing anything like that, what I want is I want this y all by itself. Now, is it all by itself? Hopefully you don't think so, because you see this big old negative 5 right here. So just like we would have up here, how do I get rid of a minus 5? Well, you add 5. But if you add 5 to that side, you should also be adding 5 to this side. So let's draw our line all the way across. These 5s will cancel out, and you end up getting y is equal to. Now here's where a lot of students make mistakes. They say that this is 2x. But there's a really big thing that we talked about up here when I asked, are these two like terms? Obviously not, because this one has an x and this one doesn't. Well, same thing down here. This one has an x and this one does not. So we cannot combine them. So instead of combining them, what we're going to do is we're going to write them differently and write them how you're used to seeing it. Because we can. A lot of times when you were younger, you saw adding like that. Now, that obviously is 7, but if I go like this, it really is no different. It's still just 7. So instead of writing it up and down like I have right here, we're going to write it sideways. So I'm going to just write negative 3x, I did not touch it, plus 5. Now, this is an equation in slope-intercept form. You have seen stuff like this all chapter. So all you got to do now is find out what the slope and what the y-intercept is. Well, the slope should be pretty easy. It's what's attached to the x. So it's negative 3. Do not put negative 3x. And my y-intercept is a coordinate of 0, comma 5. Okay, so now let's just graph that. 0, comma 5 starts right here. I need to go down 3, 1, 2, 3, and over 1 to find my next coordinate. Now I could just use a ruler to connect these two, but I'm going to do that a couple more times to get a couple nice points. 1, 2, 3, over 1. And now that I have all that, I'm going to make my line connecting all these coordinates and put arrows at the end. So that's it, guys. Let's try a couple more just to make sure we have this. So on the next page, I have another one right here. Y plus 3x equals 6. I'm going to draw the line down, separating both my sides. And I'm going to ask, just like I did before, is this y all by itself? Well, what's making it so it's not by itself? I have this positive 3x. Well, just like before, how do I get rid of a 3x? Back on this last problem, how did I get rid of this 3x? Well, I subtracted 3x. So over here, I'm going to subtract 3x. But if I do it on this side, the rules of equation say I need to do it on this side. So I'm going to subtract 3x's from both sides. I'm going to say y, these cancel out, equals. Now, it really does not matter which one you put first. I'm used to putting the x first because I like y equals mx plus b. So I'm just going to drop this down, negative 3x. And then this 6. Because it's positive up here, you need to say plus 6. So now when I graph this, my y-intercept is 6. And just like before, I need to go down 3 and over 1. And if I do that a couple times, I will see a nice pattern and a nice line. And there's that equation. All right, So for the rest of these notes, I have you trying two more, one on this page and one on the next. Would you please pause the video and see if you can do it without me? And then hit play, and then you can check. So why don't you do that right now? All right, so hopefully you had a chance to try these. I'm going to draw my line down to separate my two sides. I'm going to get rid of whatever is with the y, which is a -4, so I'm going to add 4. I'm going to add 4 to this side, and I end up getting y, these cancel out, equals, these are not like terms, so all I can do is write them right next to each other. -3/2 x plus 4. After doing that, my slope is -3/2. My y-intercept is 0, 4. So now let's graph this. 0, 4, go down 1, 2, 3, and over 1, 2. And if I do that a couple times, 1, 2, 3, 1, 2, I will get a nice looking line. 1, 2, 3, 1, 2. Make sure your line goes all the way across your graph, and make sure it has arrows on it, please. All right, so there's the first one. The second one, I don't think is any more difficult. Maybe finding the slope is a little bit more difficult here. So when I draw the line down, I need to get rid of a plus x, which is pretty easy. You just subtract an x and subtract an x. These cancel out, so you're left with just y is equal to 2 minus x, or like I did in the last example, I like to put the x first, -x plus 2. So now on here, all I need to do is put my y-intercept, 0, 2, and use my slope to find my next point. Now, a lot of people forget what the slope is when there's no number. Remember, there's an imaginary 1, and because it's a negative, I'm going down 1 each time. So down 1, and then over 1. Down 1, over 1, a bunch of times, and there's my pattern for this guy. So hopefully that was enough practice for you, where now you can do the homework for it. Before we do that, though, let's do some final thoughts. I have a couple of them for us today. An equation should be in slope, intercept form before you graph it, which is y is equal to mx plus b. Now, m stands for slope. And again, slope is just rise over run. That's how much I'm going up and how much I'm going over. Now, when I say how much I'm going up, it's not always going up. If I have a negative slope, that means our line is going down. We had a lot of those today. B, on the other hand, this guy, stands for y-intercept. And it's where your line begins, starts, anything like that. I'm going to put starts. And to move a number to the other side of an equation, you need to do the opposite. And that's nothing new. All I'm trying to say is there, to get rid of a positive x, we need to take away an x. So that's it for these notes, and thanks for watching.